Hi, this is Stats, Chapter 6, Test Notes. Okay, so you already did these problems, and we're just going to take some notes on another piece of paper. And so this is actually what you're going to turn in. And I'm going to tell you which questions to watch, maybe one more time if you watch this video, and just kind of jog your memory about these, because I have changed the facts a little bit. Okay. So in question day 42, it says there's an office with copy machines, different models. Here's the problem of each one working. And you have to remember to fill this in. This would be the probability of them not working. Now I've changed around the problem, but the logic is still the same. So it's saying, what is the probability that all three are not working? So this is what I want us to think about. And this is what he says, but he actually doesn't write. So what we're going to do in the review video is actually write down his thinking. Because he doesn't write that down in the video, but that's what he's thinking. So if you think to yourself, for all three of these to be broken, that has to be this one's not working, and this one's not working, and that one's not working. So I'm going to write that in my notes. So day 42, just to talk about my thinking. So when they say all broke, they technically mean the probability of all broke would actually be the probability of not A working, and we can use a symbol or just the word all capital A's, and the probability of not B working, and the probability of not C working. And that's what all of them broke would mean. And we just need to multiply each time here when we use the and, because that's what we need. We need both situations to happen at the same time, and both of them are independent. Okay, so when they ask the question, I'll go back to my notes here. He didn't write any of this down. You don't have to write it all down either, but this is his thought process. So it says, what is the probability that at least one is working? Well, let's think about this for a minute. There's lots to calculate if you had to think, okay, that would be 1 and 2 is working, or 1, 2, and 3 is working, or 2 and 3 is working. There's a lot to calculate there. So it's a lot quicker to think about two situations that are mutually exclusive and exhaustive, two specific situations that add up to 1, and that's the shortcut. So this is a shortcut. Okay, so if you do enough of these problems, you realize the shortcut that when they say the word at least one, we've developed as mathematicians a shortcut, because at least one working technically would be the complement of none working at all. So if we think about all broke, the probability of all of them broken, that's every single one of them broken, and at least one working, has to add up to 1, because at least one is working or none of them are working, and those have to add up to 1. So a shortcut, if this is in fact what I want to solve for, I can subtract the probability of all of them broken on both sides, and now I have a new formula. At least one is equal to 1 minus the probability of all broken. And that's what he's doing in the video. That's exactly what he's doing. And what worked out nicely is the question just previous to that, you already calculated that. So you had that number there. So you just took 1 minus that, and you were able to calculate at least 1. Very popular question. Okay, let's look at the next one. It says the probability of copy A or copy B is working. So I could change that up, but again, I could add 2 or 3 or 4 of these. And this is just adding it up. So the probability of copy A working and copy B working technically would be adding, because either of them are working. I don't need both of them to work at the same time. Just copy A or B or both would be fine. So I would add those. Correct? But then I believe in the video that in the formula you would subtract when they were both working, because they're independent. So make sure you watch the video, because he is using some more logic. Rewatch the video or revisit your notes there. Okay, remember we're adding though. This is the idea of adding. Now last, what's the probability that only C is working? So that's something very specific happening. That would be not A working, not B working, and C be the only one working, and I'm adding and adding. I'm anding, and I'm anding. So I'm going to multiply those things. Okay. So sometimes I'm grabbing these probabilities and sometimes these, and it's very specific to the question. So anyway, here's some notes I took on day 42. I would suggest both watching this, taking some notes, and revisiting the video and your notes so you're really familiar with that question. Okay, now let's go to the next day. Definitely study day 42. And make sure you're comfortable writing out bins in this question. Okay, so in this example, it was popping or not popping. So popping was 25%, not popping was 75%. So we had a probability of success, and success was not popping. So the probability of success was not popping. So we have to make sure we keep that straight in our mind. And in here was 12 because there was 12 in a pack. So this is easy to switch it up. And this is independent. We're presuming each one was independent. So, but I'm writing not a lot at all. You should be prepared to write quite a bit, like we've been writing in class, or like he wrote in his notes if you need to rewatch the video. So the probability that they don't pop, if all 12 from the pack inflate without popping, the probability of that would be not popping and not popping and not popping and not popping and not popping 12 times in a row, and so that's that formula. Can I do it in a calculator? So one benefit with me here is actually showing you how to do it on this calculator because he doesn't have the same calculator as we do. So if you go to menu, probability, distributions, go all the way down. This menu is pretty much the same. I want to go to binomial PDF, and I want to find out what happens if we do have 12 trials, 12 balloons, probability of success is 0.75, and what if we have all 12 do not pop, 12 successes in a row. And I hit enter, and there I got the same numbers he got in the video. His calculator works a little different than ours, so I think it's very useful for me to show the video so you know how to use our calculator. And again, to get credit, we want to write what our calculator screen looks like because we don't want to miss out on points. So 12.75 and then 12. Okay, that's what I typed in the calculator to get this outcome. So just copy your calculator screen. Next, all the balloons from the first pack inflate without popping. That's what we calculated here. Should they keep the other packs? Well, I think that's obvious. Just review your video notes there. They were expecting a quarter of them to pop, and none of them popped. So I think they're pretty good. Now, last but not least, it says given they first, now if this is independent, it doesn't matter what happened before. When we look at the 13th balloon, it has a, what's the probability that it will pop? So it says the pop happened. So there's a 25% chance of popping because there's a 75% chance of not popping. So that's 25. And then what about popping on the 15th? This is similar to what we've done the last few days. 13th doesn't pop, and pops. 75% chance it does not pop. That's a success, failure. Okay? Now, it's pretty obvious using logic which one is more likely to happen. Please make sure you explain because it says, given which event has the same probability, and tell me why. Check out the next video to figure out which other days will be on the test. Thanks for joining us.